Hello and welcome to Don't Plug It In, and I guess this is volume 7? Yes, this must be 7. I'm the radio mechanic, and today I have something here that I hope will be of interest to the young players, and some of the old timers may or may not know this. I bet they know some of it. I'm going to start out with a question. Does anybody know what this is? This thing right here. How about you? No? You? How about this guy? I bet most of you are saying, well, dumbass, that's a power cord. Well, yes, you'd be partially right. It's also one of the many ways this radio can kill you. What this actually is a 120 ohm, 6 foot long, roughly 20 watt resistor, which gets very warm when the set's running. And if the lady of the house back in the day had this up against the wall and plugged it in and had some heavy curtains laying on top of it, it can get hot enough to start a fire. They're fine when they're spread out over their full length and nothing's covering them up so they can dissipate the heat, but nobody ever gave that a thought. And it's dissipating somewhere in the neighborhood of 15 to 20 watts when the radio is running. And you say, oh, that's not a lot of power. Well, this is a 7 watt lamp. Let's see you hold on to that after I turn it on. Once you confine all of that heat into one space, it's dangerous. That's one of the problems. Another one of the problems is it's asbestos, most likely. Most of these were, just because they got hot and they didn't want them starting fires. I'm probably way too old to worry about mesothelioma. All the brake jobs I did as a teenager are going to get me. Another problem with these is this sheath tends to break loose and slide back like this one. And what you have in here, if you can see it, see the spiral on this wire right here? That's the resistive element that drops the voltage for the tube string. And if you were to grab this thing and pull it out of the wall while you were leaning on the sink, well, you know what's going to happen then. Bad day. So it can electrocute you, it can burn you to death, or it can give you lung cancer. And that's not the end of the fun with this set. Look at the room in here. I can reach right underneath the chassis. I can stick practically my whole hand under there. Imagine some kid, curious hands getting in there. And number one, this is a true hot chassis. This is connected directly to the line. This doesn't have an isolation capacitor like the last couple of sets we worked on. This is connected directly to the AC line, albeit through a 30 ohm resistor, but that 30 ohm resistor isn't going to save you. The AC power comes in. This is a crazy set. The AC power comes in, and we have our curtain burner, and that's about 120 ohms. Now the math that's on here, I was figuring out powers, power dissipations and resistances, and what I was going to have to do to modify this to get rid of this cord. My numbers are based on cold calculations and voltage drops that the tube nominal voltage drops, so the values will vary a little bit, but these numbers are going to be real close. This line cord resistor measures 120 ohms. Comes in, goes through our rectifier filament, down the rest of the filter string, or filament string, heater string, and then it goes through our dial lamp, which is paralleled by that 30 ohm resistor, which is bringing our AC down here to the chassis. Right now, as close as I can figure the math based on a hot filament or a lit lamp resistance of 25 ohms, and this resistor here, which we end up with an equivalent of about 14 ohms, it looks like it's going to be about 9 volts across this number 44, and that's a 6.3 volt lamp. It probably isn't as bad as those numbers seem to indicate, because we're going to get some voltage drop on this when it warms up. This resistance of this will probably go up, I'm guessing. According to my numbers, based on my best estimates, it should be 128 ohms. So we got 128 plus an additional 14. Well, on top of the 20, we got 134 ohms. So 128, 134, the numbers seem to work out. It should be okay. My plan is to replace this guy with one of these. I've got 120, I've got 150, and I've got some other capacitors that I could parallel up and juggle values around, but I think the 120 ohm one I have will be okay. We'll find out. I'll take some voltage measurements when we get going on this. And these are capable of dissipating 50 watts. So this is at least twice the dissipation we need heat-wise. It should be fine. Another interesting thing on here the youngsters probably haven't seen is this set has a field coil choke. Let me get this out of the chassis here real quick. This is our field coil. What this is an electromagnet. Instead of having a permanent magnet in the speaker, we have an electromagnet, and it serves a second duty as a choke, a filter choke for the power supply. They do a better job of smoothing out the AC ripple by, to keep the current flowing than a resistor normally would. Now this other set we had, it sounded, this set was absolutely fine, but here's our friend the pi filter, and it's using a resistor in between our two excuse me, filter caps. Again, here's our friend the pi filter, only this one's using the choke. And more high-end sets tend to do this all the time. Usually the more expensive sets always use the field coil. They got away from it in later years, but it filters out the AC very nicely, plus it allowed them, back in the days when they didn't have great magnets, to have a decent speaker. So, we have, and for the young players, these two formulas right here are the two most important things you're going to work with when you're working on these radios. Yeah, you can look up, capacitive reactance, inductive reactance, and resonant circuit stuff, but you're going to be using these every time you're in one of these sets. This is Ohm's law, and this is power dissipation. And it's simply E over IR, or PIE. You can just remember pi. And you put them in this configuration so you multiply across, or you divide into the top number this way. In other words, voltage divided by resistance will give you the current, or current into the voltage will give you the resistance. That's how you calculate all these numbers to come up with, what I should have for resistance, what my power dissipation is. Now, based on just having the tube filament, and I'm guessing roughly 100 milliamperes for the B plus supply, because that's about what the Traveler used, was about 100 milliamperes to drive the tubes, all the anodes in the tubes. So I'm going to guess about 15.4 watts are going to be dissipated in this resistor. It may be higher, maybe as much as 20, but that 50 watt resistor that I'm going to put in there will more than easily handle that. Let's take a look at the tube lineup. This is the schematic from our Traveler. The one tube, or actually two tubes, the rectifier is a different tube, but as far as the RF circuitry goes, there's only one difference in the tube lineup. Instead of an SK7, we have an SJ7, and it's a 6-volt filament. The first number is just your filament voltage. But the two tubes have the identical pin out. Every pin has the same function between the two of them. Different heater voltage, different heater current ratings, and there's maybe some minor differences in the emissions, how much grid voltage it has to have, yada yada yada. But I would bet that if they had equal, if you had a 6SK7 and a 6SJ7 in a set with a transformer, I bet you could just interchange the two tubes, and I bet they'd work. But if we get on the rest of the line, it's the same tube, 6SA7. It's a 6 volt instead of a 12, but it's the same tube lineup right down the line, which means our circuitry is going to be nearly identical. Of course there's going to be differences. There'll be some capacitance differences and some resistance differences. Every designer comes up with his own slightly different configuration, but we're going to have our AVC line going through the antenna. We're going to have an AVC line because it's a 6-tube set going to our IF amplifier. It will more than likely bypass our converter or mixer tube. It's going to be so close that you'll be able to use this schematic to mostly trace everything on that set there. Going to be almost the same. The rectifier on the last set was a half-wave rectifier using a tube with a single anode and a single cathode. This set is using a 25Z6, which has 2 separate anodes and 2 separate cathodes. But what they've done, which they do very often, is they've just hooked the 2 anodes together, they've just wired the 2 cathodes together, and they're using it as a half-wave rectifier. So if you had the 25 volt version of the Z5, which is a 25Z5, you could probably, if the pinout was the same, you could always just change the pinout around if you could substitute one for the other. Again, based on current rating. I guess that's about it for this. Oh, this little guy right here that I've drawn in, take this piece of wire out of and this little loop that I've put in is this loop of wire right here. It's in the same place of the circuit that I've drawn on the schematic here. It just breaks the line into the volume control coming out of the detector tube. I'm going to go out on a limb here and say that is a humbucking coil, or a humbucking loop. This is the end of the filament string. This is where all the current in the filament string ends up going to the chassis and then out to the AC power line again. This loop is probably set up so that they're hoping it's going to be 180 degrees out of phase with any hum pickup that's going on in the system. And this being out of phase, it's going to capacitively couple, or inductively couple, excuse me, or maybe both, to this wire back here to some extent, and hopefully reduce the hum. That's my best guess on what that is. We don't have the schematic. And that brings up something else I want to mention to you, is if you ever see anything that looks like this in your radio, you know, it could be in the RF section, it could be in the IF section, it could be in a shortwave receiver in the BFO, beat frequency oscillator. Don't mess with it. Don't cut it out thinking that somebody's clipped something out of here. This is what's called a gimmick capacitor. And these were made because they needed a small value cap, something in the order of maybe 2 to 7 picofarads. If you made them longer, you could go up. And what they would do is solder a couple wires in, twist them together, and test the circuit. And if there wasn't enough capacitance, they'd twist them some more. And when they got close, they'd cut them off. If there was too much capacitance, they could nip them off a little at a time, or they could untwist them. This used to be a very common method of installing small value, handful of picofarad capacitors. So don't think this is something that somebody just cut out of the circuit at some point, or an experiment. These were actual components in the radios, and you will sometimes actually see them on the schematic. It'll point to a capacitor, it'll have the capacitor symbol, but it'll say gimmick. And this is what they mean by a gimmick capacitor. What else? Oh, I went through here, and while I was checking the filament circuit, I checked the dog bone resistor here, because you're always suspect of dog bones to begin with because of their age. They tend to go way wildly out of tolerance, and the big ones like this are usually dissipating quite a bit of power. I was utterly amazed that all of the dog bones in here are well within 10%. Even though a lot of them are 20% resistors, there's no silver or gold coating on them. They're 20% resistors. They're all within 10%. I was just blown away at how good all the resistors were in this thing. All the heaters are good and intact. We can probably attribute that to this great big resistor in the circuit, because when you turn it on, most of that surge will get sucked up. You know, your tube heaters are going to be cold and their resistance is going to be fairly low, handful of ohms, maybe 10, 14 ohms. So when the thing comes on, this 120 ohm resistor soaks up most of the surge, as will this guy, and takes it a lot easier on the tube heaters than the standard series string, which doesn't have a dropping resistor. It just relies on the resistance of the tubes when it comes up, and when they're cold, their resistance is very low. If you measure a light bulb, for instance this number 44, it's probably 5 or 6 ohms or less when it's cold, when you measure it with an ohm meter. But if you do the math, the 6.3 volt lamp, and it's rated at 1/4 of an amp, 250 milliamperes. If you do the math, when it's hot, it's 25 ohms. Same thing happens to all of your tubes. The resistance goes way up. And I'm expecting this to rise a little bit too. Why don't we do that in a normal AC/DC set? Well, you can. Some guys do install resistors to take up the surge in the standard series string sets. The problem is those sets, they're putting the resistor over here, and when you do it there, that voltage drop on the resistor, which is going to be there all the time the set's running, because the filaments will be drawing current, and it does a good job of soaking up the inrush, but it's also going to have a voltage drop, which means the filaments aren't going to get their full 6.3 volts or 12 volts or whatever they're designed to do. So their emission is going to be down, and if the tubes are old and weak, that's going to lower it down even more. And if the resistor's here, your anode voltage goes down. You lose your B plus voltage. That's going to drop by 10, 15 volts as well, or whatever is the drop across whatever resistor you choose here. Whereas these sets, their AC line goes directly into the rectifier, so there's no voltage drop. And the series string is calculated to accommodate the voltage drop. So this is why it's okay in this type of a set just to throw a resistor in it. It's a little bit different setup. Another thing, this is a replacement potentiometer. You can see it's blue in color. It's much longer than its brother down here. I'm going to have to cut it off because that knob was sticking out further. But fortunately, when they installed it, they gave me one that's got a double pole switch. It's got 2 sets of contacts in it, 2 separate individual switches. What I'm going to do with this set when I put it back together, because it's impractical to get the line off of the chassis, there's too many points in this radio to tie to the chassis. I'm going to use the second set of contacts over here and put that switch there. Am I in frame here? I hope so. So what's going to happen, normally when you open the switch, it was in the ground side, so your hot AC would still go through here, and you'd still have 120 AC on the chassis, even though the switch is off, because the hot side's going to come through the filaments. It'll pass 300 milliamperes, and that's enough to kill you. But I am going to hook the neutral side here, the hot side here, and I'll use the other set of switch contacts. So when I shut the set off, both sides of the circuit go out. The radio is totally inert except for the line cord itself, which will be a standard normal line cord. But there's got to be something else I haven't told you here. Too much coffee. My mind's going 100 miles an hour, and my 286 processor's not up to that. Coffee. Oh, I know what I was going to say. I would love to find replacement potentiometers and switches for all of these sets, and I would wire all of them with these dual switches so that the set goes completely inert when it's off. That way it just ups the safety factor enormously. The problem is finding the correct resistance in an audio taper pot with the double set of contacts, which aren't all that common, of the right length and style shaft. And it can be an all-day search sometimes, just finding a replacement for a regular pot sometimes that has the right length and the right style, because they come in so many different lengths. Most of them have the serrated or fluted type of shaft. Some have a flat. Finding that right combination can be very time consuming, but if you're willing to do the research, you could certainly render your radio a lot safer by switching both the line side and the neutral side. Just that way, if the plug's in either way, the radio, when it's off, is off. There'll be no voltage on the chassis whatsoever. What have I done to this set so far? Well, I've checked all the resistor values, as I said, and I've noted the differences in the power supply. I've noted what else? We've discussed. I'm trying to remember. I guess that's pretty much covering everything. I have not tested any of the capacitors yet, so I'm going to set up, do that quickly. We'll change a couple of caps, see if this radio wakes up. And if it does, I'm just going to recap it. I'm not going to bore everybody with alignments. Everybody's seen that ad nauseum at this point between my videos and everyone else's videos. But what I wanted to pass on to everyone out there, all the young players, was how different these sets with these curtain burners systems can be. And you've just got to sit down with the radio and your tube manual. You do have a tube manual, don't you? And you just drop a simple schematic and just trace out the wiring, and you'll get an understanding of what's going on and how it's operating and how you can replace this resistor. Okay? It's not hard, it just takes a little time. And if an old man like me can do it, I'm sure. Aha, I thought I was going to get away with it this time. I've got the camera plugged in, I've got it plugged into the wall. I said we're going to get through a video without the camera shutting down, and I was wrong. I don't know what's going on, if it overheats or if it's just dying from old age like me. But what was I saying? Don't remember. I guess it wasn't important. Oh, I'm not going to bore you with alignment and all of the tests. We'll just take a quick look at the filter cap to see how that fares, and then I will, off camera, offline, I will go ahead and recap the thing, and we can see how it works, or if it works. The electrodynamic speaker was pretty crunchy when I got the set. Move this down here, change our view a little bit. Dun, 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 dun. There we go. I've forgotten what I was saying again. Gone right out of my head. Oh, the speaker. The speaker was crunchy when I got it. I laid the radio so the cone was facing down, so the open part of the voice coil, it had another one of those speakers with the open voice coil. I have since put some felt over it, but I just tipped it upside down so the cone was facing down, and I just kept working it and working it and working it, and it quieted down. Most of the dust and dirt fell out of it. So it may be okay. We may get lucky again and have a speaker that's alright. There was one tiny tear in it. I used liquid electrical tape to fix that up. Alright. We'll connect this to the ground. I'm not going to put it on that wire. I'll put it over here because the capacitor goes directly to the chassis. This filter cap is soldered to a lug that's right behind the volume control. And there's our... Should I use my other one? Our filter cap goes right here. Okay, let's see what happens. I'm betting dollars to donuts this cap's no good. I'm going to turn on the DC here, and then we'll do our test. Absolutely nothing. Didn't blink at all. We're drawing a tiny amount of current just off the zero, and it drops. But those capacitors are absolutely gonzo. So I'm going to have to replace the filter caps. It's another 50 and 30. I'll put a 40 and a 20 in there. It'll be fine. And I'll find I bet I got a leaky coupling cap. You've seen me do that. I'm not going to get into that again. I'll change the coupling capacitor for the audio output tube. I'll put a couple of filters in there, and we'll see if this thing will wake up. And then off camera, I'll just recap the whole thing. So we'll be back. I'm in here working. I've spotted evidence that somebody has been here before me for sure. It looks like one of the IF transformers may have been removed and replaced. You can see right here there's a J-hook connection. This wire goes up into the IF transformer, and up here there's another J-hook. I don't know, I don't want to overexpose. There's another J-hook right here. That's another IF transformer wire. So somebody's had the IF transformer out of this set at one point in time. Let's hope whatever they've got in there is the right one. That's another reason I don't shotgun everything. I want to make sure that the set's going to be viable. There's continuity there, but that doesn't mean that that's the right transformer. Another point of concern with these sets, and this is something I checked earlier and neglected to tell you, the field coil on the speaker. Are we in frame? I hope so. Yeah, we're in frame. The field coil on the speaker, it's not uncommon, it's not unknown for those to be open on some of these sets. And if they do, you're kind of at a dead end unless you either have a replacement speaker or put a permanent magnet speaker in there and replace the field coil with a resistor. And it can be anything from 500 to a couple thousand ohms usually. And when I'm working on a set like this, I don't have a schematic for it. I'll check the field coil. This one happens to be 550 ohms DC resistance. Now that's not its AC resistance when it's running, but it gives you an idea that, okay, I've got continuity there, and maybe I could start with, you know, a 600 ohm and check my B plus voltages and listen for hum if you have to replace it with a resistor. And it's not uncommon to have to do that. Or if you have a bunch of electrodynamic speakers with the field coils in your junk box, if this one ever failed and you've noted it on a schematic, like I'm making notes on the schematic here, that it's 550 ohms, and if it ever goes open and I have a speaker in the junk box with a field coil of that resistance, I can drop it in there and replace it. Also, tubes like the 25L6. The L6 series, they're a Class A amplifier. They run hot because they're on half throttle all the time. It's the hottest running tube in the set. And I usually take a look when you're working under here. You can see the bottom of all the tube pins. And I don't know if you can see, some of those solder joints look like they may have oxidized a little bit. And that can be no end of problems if you don't notice it or know what it is. You can get intermittence. So I'm going to clean those up, take a look at them under magnification, and if I have to, I'll touch up the soldering on those. You got to be careful. You build up too much solder on the pins, you're going to damage the tube socket when you plug it in. But if you're real careful and you use a little flux and clean everything up well, you can usually correct these without too much of an issue. Another item to keep an eye out for is any place where there's a grounding lug that's held on with hardware, like there, down here. If that's still in frame, yeah, just barely. This one down here is they're just screwed, little solder lugs screwed to the chassis. We got one there, we got one here, we got one here. There's one under the volume control. Do I spot any more? It's ground, it's common ground. Nope. Sometimes they'll be grounded through a lug on the tube socket. After 80 years, those connections are always suspect. Go around, tighten them up. If it's under a nut like this one is, get a nut driver and sock those down good and tight so you have a good ground connection. Some of the better sets, you'll see the leads actually spot welded. If they're grounding to the chassis, you'll see where they've spot welded 2 or 3 places on a lead. Those connections typically never fail. If you've got a good soldering iron, like this bad boy, this is the big brother to this one. You can use, I use number 10 house wire and make my own tips, and you can solder directly to the chassis with this and, you know, get a very successful solder joint. And actually, if you want to take the time, it isn't a bad idea to solder the lugs to the chassis, but that's probably overkill. So just be aware that on these, a lot of these AC/DC sets, there'll be 100 grounds on them, and the cheaper ones are just nuts and bolts. Kind of like a Heath kit. Okay, we're going to break this video here. It's up over half an hour. I'll be releasing part B fairly soon. I do want to do a couple of shout outs just before I close this. I want to thank Rich Fram, I think it is, who directed me to Airspruce, or aircraftspruce.com. I used to buy stuff from them. I bought a lot of stuff from them over the years, actually. But he says they have the little clips to go in the back of the cabinet on the other radio. They call them I forget what the heck they call them. Here's tri-mounts. Here's what they look like. And here's the information if you guys want to contact them and give them. They're a little pricey at $1.10 a piece, but they're aircraft parts. So anything for an aircraft, you can multiply its worth by about 30. But again, thanks Rich for passing along that information. Appreciate it. And I got a nice note from Bill, KI7Z Alpha Delta. And people he's directing me to these anatherms placed on eBay. The problem, Bill, is their lowest rated one is 2 amps. We're trying to find these that are rated under half an amp, because if they don't run at their full rated current, they never drop to their low resistance point. They have to get pretty warm. And the lowest current one that he had on his website anywhere was the 2 amp version. And if we follow that across, at 25% of the 2 amps, it drops to 2.94 ohms. Am I still in the right line? No, sorry. It drops to 7.8 ohms. It only goes down to 7.8 ohms. At 50%, half its rated current, 1 ampere, it's still at 3 ohms. At 75% of its rated current, it finally drops to 1.75, and then at 100%, it's 1.18 ohms. The problem is we need these to run in the half amp region so that they get warm enough to drop to a low enough resistance that they're not causing a big voltage drop. And I really, I know somebody out there has these in inventory. They must have leftover stock. Of course, yeah, that may not be true either. I know when I was working, if we didn't use inventory, in 6 months they'd purge it and throw it away. It used to drive us crazy. In fact, when we had to go out on, I'd have to go on the road to service equipment. Before we left, we'd dumpster dive and find tooling that they threw away because it hadn't been used or ordered in 6 months, because we knew we were going to need it on the road. It used to make me nuts, the thousands and thousands of dollars of inventory that got thrown out every 6 months. I was just hoping somebody out there might have done the same thing, gone dumpster diving at their company and taken these home, but I still think there's a business opportunity here for somebody to contact one of these companies and buy 5,000 or 6,000 units and then turn them around for $1 a piece or $2 a piece, because they sell for next to nothing. in volume, you're paying, you know, 30 cents a piece for these things. Okay, that's it for part A. Part B will be out as soon as I can get finished editing it. It's the holiday season. We got things going on, but we're going to try to get it out as quick as we can. Thanks for watching. Appreciate all my viewers. Even the guys that give me the thumb down. It still adds up to viewing hours. See ya.